I am Sandeep. Today we are solving a question from April 2022 Rajasthan Technical University's end term examination paper. The question is from part A, and we have to prove that the Boolean identity laws of Boolean algebra obeys this one: A plus B ANDed with A plus C plus reads as OR equal to A or with B and with C, ANDed with C. So and OR operations are there, and you have to prove the following identity using the laws of Boolean algebra. So straight away the law that applies here is distributive law. One solution can be this one. Using distributive law, on the left hand side we can evaluate the brackets and progress like this as shown. If you want to go step by step, you multiply A with A and C to get this, then B with A and C to get this, taking out A common, and when we pull out A literal or variable, whatever you want to call it, outside, then there is another OR operation. Logic OR says one OR with any literal will give you that literal. So if you see a logic table of OR gate, you will get this. So that simplifies to 1, and you get A OR with BC, which is equal to RHS. If you are running short of time, and if you want to complete your paper quickly, you can write like this. The same equation can be written directly by operating the brackets. Then you pull out A common, and then it falls equal to the RHS side. So, and at the end you can mention I used distributive law and OR operation. Now if you are not happy with the solution, you can solve and then give reasons also. So the reasons are these, that first let us develop the need for the reason. When we try to solve this problem starting from here, we say we operate the brackets, and then after operating the brackets you end up with the position of having two literals ANDed with each other. What do they mean? So what they mean is that A ANDed with A gives A, because 0 ANDed with 0 will give 0 AND operation using AND gate, and 1 ANDed with 1 will give 1. So if A is equals to 1, it will be 1. So A dot A will be A. If A is equals to 0, then 0 dot 0 will be 0. To prove this behavior, that A ANDed with A, which is both 0, both inputs are A, gives a 0, and if both inputs are 1, gives a 1. To prove this circuit is used. The logic is developed from this circuit where two gates are there. Inputs A and B are switches, and there's a battery and a bulb. So if A and B are both off, then current will not go and the bulb will be off. So off will be off. Both switches off will result the bulb being off. So 0 0 is off. Similarly, if one of the switches is on, still the bulb will be off. If both switches are connected, both switches are on, then only it will be on. So this is the behavior, which is the logic truth for this circuit. A circuit has got this symbol, and this behavior of the circuit ends up as truth table. So these things go back to give us these results, and these results when used here gives A dot A equal to A. Then 1 OR with B, how can you say that 1 OR with B becomes 1? To prove that, again there is another circuit that can be used. This circuit is circuit of OR logic, and in OR logic there is a battery. There are two switches A and B, and when you have one of the switch is on, so let us say this is equal to 1 1, and the other switch, let us say it is off, or in another condition let us say it is on. Whatever may the case be, if single switch is on, the current will reach the bulb and the bulb will light up. That's why I have written A or with B or with C will end up 1. So this is the complete proof for your satisfaction, but this answer is sufficient to get you marks. How many marks does this question carry? This question carries only 2 marks. So this is a good explanation and an answer sample for your RTU exam. Thank you.